Hi guys, here is another question. A solid disk of radius a and mass m rolls down without slipping on an inclined plane, making an angle of theta with the horizontal. We need to find the acceleration of the disk so that we can find out the value of b in this case. So this is the setup. What we know that this is the disk. Let's say we have the weight component of the disk directly pointing directly downwards from the center of mass of the solid disk, like this is mg. This is the friction force as it rolls down without slipping. This is the normal reaction force. It moves with the angular acceleration alpha. The a over here is the acceleration on the plane over here, and this is the FBD of that case. We know that the vertical forces on that ball should be equal, so mg sine theta minus f should be equal to ma center of mass, or I, alpha a is g sine theta upon 1 plus k square by r square, correct? And we know that f into a is ma square by 2 alpha for the disk. So k square by r square is 1 by 2. Using the value of k square by r square, a into sine theta, a center of mass, this is a center of mass over here, is alpha into a, which is a is g sine theta upon 3 by 2, which is g sine theta upon 1 plus 1 by 2, which becomes 2 by 3 g sine theta. And on solving, we know that the center of mass has this velocity, this acceleration, and if you look, 2 by b g sine theta was the acceleration mentioned in the question, so b becomes 3. Thank you.